Circles. We're starting circles. And so these are all the little definitions that we need to know. If I say circle, center, radius, chord, diameter, secant, tangent, if I say any of these, you need to know what I'm talking about. So I'm going to run through these real quick. Circle. A circle is a set of all points in a plane that are equidistant from a given point. In plain English, all these that make this line, this circle line right here, are the same distance from the center of the point, of the circle, excuse me. The center of a circle is a point from which all points of a circle are equidistant. Again, so it's basically the reverse of the circle. The center means that from this point, every point here is the same distance. Radius, a segment from the center of a circle to any point of a circle is a radius. So from here to here. Here we go. This one right here is a radius. So a radius can be in any direction. It has to be a segment from the center to the outside. A chord is a segment whose endpoints are on a circle. Endpoints, that means where it stops, are on the circle. All right? A chord is a segment whose endpoints are on the circle. A diameter is a chord. Diameter is a chord that contains the center of a circle. So that's the diameter. A secant is a line that intersects a circle in 2 points. So it's a line. A chord and a secant are very closely related. A chord stops on the circle. A secant continues through the circle. All right? Tangent is a line in a plane of a circle that intersects the circle in exactly 1 point. So a point of tangency is that 1 point where it touches a line. Where a line touches a circle. Now, tangent sounds familiar, and if we would have went deeper, these two should have sounded familiar when it comes to circles from trigonometry. But we only talked a little bit about sine, cosine, and tangent. But this is a little bit of tangent, a little something that's different actually. So don't get it confused with the tangent that we talked about, which is what, opposite over adjacent. This is not that tangent. It's just a line that touches a circle in one place. That's called a tangent. All right. Now, look at all of these and see if you can figure it out. Like what goes where. You match this up. I'm going to pause it and you match it up, meaning you should pause it because I'm about to put the answers up real quick. Okay, so here's the answers here. Couple of things. Common external tangent would be DE. That means it's common, meaning common in math. Usually more than one use it or share it, and it's on the outside of the circle. And a common internal tangent, meaning it's between two figures here, would be the HF line here, or FH. One thing that's important is on some of these you can't see, but they have the little arrows on the end of it, so they're talking about a line and a segment. So for example, chord AB is this one. See how it don't have arrows on the end of it? But secant ABH here is very small, but it has the arrows on the end of it. So remember, a secant and a chord are very closely related. A secant is the line that continues, and the chord stops on the circle. You got questions about any of this, let me know. All right, so here's our first theorem. This is the stuff that we need to know. In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle at its endpoint on the circle. So basically what this says is from a radius, which is from the center to the outside of a circle, and you have a point of tangency there, whenever that happens, it makes a right angle. All right, so that's something to keep in mind. We have this example right here. In the diagram, RS is a radius, so we already know if it's a radius and there's a point of tangency there, then automatically we know that this right here should be 90 degrees. Is ST tangent to, so they're asking, is this tangent to this? And you know how we prove that? We know all three sides. So how do you think we're going to prove that this is tangent? Well, if you said that the Pythagorean theorem should be proved, you're absolutely right. If a squared plus b squared equals c squared is actually true, then it has to be a 90-degree angle. And so, let's try it. let's look at, see if Pythagorean theorem will actually come true. So we're going to say 24 squared plus 10 squared, and that equals 676. Remember, the hypotenuse is always the longest side, so that's c squared. So let's see what c squared is. 26 squared equals, and notice that they're the same number. So what does that mean? That means that the Pythagorean theorem is true. A squared plus b squared equals c squared. So this must be tangent. So the answer to this question here is yes. Now, why did I do that? Let's understand that from here to here is a radius. They're saying that this is a tangency point, or asking if it is. And how do we prove if it's tangent? We know by this property that if a radius intersects a point of tangency, it makes a 90-degree angle. It's perpendicular. All right, so that's one to keep in mind. Radius always to a point of tangency is 90 degrees. Here's our next theorem. A tangent or tangent segments from a common external point are congruent. S is your common point. Common means the same. I said that earlier. So as long as you got two tangents coming off of a circle and they meet at a common point, that means these two lines are congruent. And in the equation, congruent means equal, right? So they give us this. If you understand this, this is what they do. QR is tangent, so they tell you that, at R, and QS is tangent to this circle at S. So they're telling us these two are tangent at these particular points. Find the value of X. So whenever you're given stuff like this, you know you got to set up an equation. Again, you set up the equation based on what you know. I know that if two segments that are tangents to a circle meet at one common point, then those two segments are congruent. Or in other words, those two segments are equal. So what does that mean? That means that what you have to do is go back to your paper and you say 32 equals 3x plus 5. Is it wrong? Oops, can't see that, can you? Is it wrong if I said 3x plus 5 equals 32? Is that wrong? Nope, no it's not, because it's the same thing just flipped around. Anyway, find the value of x means to do what? That's right, we are to solve. So I subtract 5 from both sides. 3x equals 27. Divide both sides by 3, and x equals 9. All right? So that's the way to use that particular property. Okay, so that's it for today. The two theorems are common tangents meeting at a common point, or tangents meeting at a common point. They are congruent, and a radius and a tangent or point of tangency meeting makes a perpendicular intersection. Okay, and based on that, you have to know the tangent and stuff like that, what we've talked about here. And so today is important because we're going to build on using these. There's all kinds of properties that we're going to discuss that deal with each one of these things here, and you may already know some. For example, a radius and a diameter has a relationship that you guys probably already know. And so anyway, these things are things that we're going to discuss, and it's important that you understand each individual lesson because this one is not that difficult. The other ones kind of increase with some of the complexities, and the pictures start to look the same. And so we have to be able to differentiate between what's actually happening in the picture. Good day, ladies and gentlemen. Hopefully you understand this. Merry Christmas.